Good afternoon, everybody, and welcome back to my channel. Today I have a brand new lesson for you on orthographic drawing and drafting in AutoCAD. And I'm in a brand new module here titled AutoCAD Orthographic View Drawings for Download. But before we can jump into that, we need to first understand what an orthographic drawing is. And we're going to take a look at an example here, which is first in the module. So this is a PDF that shows a picture. It is a picture drawing of an object in a three-dimensional view. And it has all of these surfaces here identified with numbers, as you can see. And there's an arrow that points down from above called the top view. There's an arrow that points in this direction towards the 1 labeled as the front view. And then lastly, there's an arrow pointing at the angular surface of the number 5 called the right side view. And I think I'm gonna download this just to get a better look at it. And if I scroll down, what I see are the orthographic views. Now, what does orthographic mean? Basically, we're taking 3 views of the object and we're aligning them in a specific order. So this is a method used in industrial drawings quite commonly. We generally will, when we have to manufacture a part, we need to create at least 3 drawing views. Sometimes 2 are only required, and other times up to 6 or more are required. But 3 views is basically the general rule of thumb. So this is the top view. It always goes above. In our orthographic drawing view layout, we have our front view. It always goes bottom left. And then we have our right side view, which obviously goes to the right of the front view. Now, let's take a look at the front view. It is considered to be the most important view. This view basically is the parent to the other views, meaning that the other views are basically dependents. So we see surface 1 and 2 only in the front view. Remember, orthographic views are strictly 2-dimensional. So even though this is 3-dimensional looking, we're only going to be drawing in 2D as we've been doing so far with our single view drawings. So in the front, we see this outline, surface number 1, and above it we see surface number 2. Now surface number 2 is on an angle here, but when we look at this from the front, we have no perspective of that angular surface. When we look at it dead on, straight on from the front view, we can't notice the angle. We're only going to notice the surface. And we're only going to get perspective of it from where it begins at the bottom and where it sits at the top. So it looks longer here in this view, but in the front view it's going to appear shorter. When we look at the top view, surfaces 2, 4, and 5, we're seeing that here. When you look at, again from the top, we're not going to notice that angular surface for number 2 or number 5. It's only going to look like vertical rectangles to us. So here it is, surface 2, surface 4, and surface 5, as seen here. And where the front view begins, the top view has to begin. Where surface number 2 ends, surface number 2 must end on the top view, and where surface number 4 ends here, it has to end the same on both views. Just like this angular surface number 5 here, this line, that's what this represents, it has to start and end in the same position. The views have to be aligned. We just can't draw the orthographic views and place them anywhere we want on the paper or drawing. drawings must be aligned. It goes for the same with the right side view. We're only going to see surface number 3. You can see that triangle here. We see that shape here. And we're also looking at number 5 underneath here. And it is on an angular surface as well, which we have no perspective of when looking at it from the right. So there is a little introduction on what we're going to be working on. So we're going to go back into this module. We're going to back up a step. And we're going to click below to the next. And this is called orthographic drawing problems. So this is what we're going to be working on. We're going to be working on this first one today. So this is called the control bearing. It has a scale of 1 to 1. So how this works is we're going to be drawing a view from the top. So looking down on it. We're going to be looking at a view from the front, looking in this direction, and a view looking at it from the right side, which is this direction here. Now, like I've mentioned in previous videos, I'm not going to be constantly going back and forth looking at this document. I always have these things open on my iPad next to my computer. Of course, you can't see that in this video, but I'm going to be referring to that iPad image as I complete the orthographic drawing. But I'm going to begin with the front view. So I'm going to be beginning right here, and I'm going to be drawing a line with the line tool with ortho mode up 41.5. And then I'm going to be drawing a line to the right, 44 millimeters. I'm going to be coming down 20 millimeters, over to the right, 40 millimeters, up 20, and over 44, and down 41.5, and back to close it off. I probably just use the C for close and enter. All right, so I'm going to get started. So I'm going to back up. And I'm going to go to control bearing, click on it, and I'm going to download it. Now we're just waiting for AutoCAD to load up. Okay, we're going to hit open, and we're going to maximize this window here. Zoom out a bit with my wheel and pan to the center. Now, before we get started, we always go up to the big A. We hit Save As, and we select a new location for saving our work. So I'm going to my folder, my AutoCAD drawings, and I'm going to be saving the control bearing here. Okay. Remember, always take these things out of your downloads and save them to a different location. All right, so the border looks the same as what we've seen already. The only difference is we see 3 origins now instead of 1. And this is going to allow us to draw the views in the correct position and allow the correct spacing between views and make sure the views are centered within the drawing space. So our front view is going to go in the bottom left, our top view is going to go above it, and our right side view is going to go to the right side of the front view. So to get started, we need to make sure that ortho is turned on. And we're going to begin. We're going to hit the line command. I'm going to be zooming in, grabbing the endpoint and drawing a line up. Excuse me. I'm referring to my iPad 41.5. Enter. Coming over horizontally 44. Down 20. Over horizontally 40. And I can key in 20 again, or I could just come over here with my mouse. Don't click the endpoint, but just touch it. And what it will do is create what's called an O track. So I don't actually have to input the number. I can just slide my cursor over there, touch that endpoint, and it'll preview a 20 for me. And when I see that, I can just left click. So that's another trick that's revealed for you that may help you. We're coming over to the right. Again, 44. We're coming down. I'm going to use an O track again. Touch the endpoint here. Click. And then instead of clicking to the endpoint in the origin where I began, I can just type C and enter. And that will exit me from the command. Now this window here that you see here with control bearing, that shouldn't be there. That's just a little glitch. So we're going to have to ignore that message. You shouldn't be seeing that. Moving on, we're going to start with our top view. So we're going to right click our mouse, left click repeat line, go into the origin again, the same spot we always begin in the origin as you've seen before. Left click endpoint, draw a line vertically. This is going to be 11. And I'm just reading the drawing on my iPad as I do this. So this slot is drawn horizontally 10 millimeters. And then I'm coming vertically 28. And then I can O-track this if I want, or key it in. I'll track it. It's 10. Come up 11. And I don't know. It doesn't tell me on the sheet how long the total length of the control bearing is. But again, it doesn't matter. I can just touch here and create an O-track. And it tells me, well, it's 128. Great. I'll left click. I'll come down again. Track this. It's 11. Come over 10. Come down. I'll just type this one in. 28. Come over. 10. Down. 11. And then C, enter to close. Oh, that didn't work. It closed ahead of me. So I'm just going to right click, left click, repeat line, grab the endpoint, and click to the origin, and right click and left click enter to escape. Okay, so I've got two views almost done. Now, what I need to add to this is because, and you'll see this on the sheet, there is a slot running through the middle. And when we look down on this view from the top, we have to be able to show that slot. So I'm just going to go back for a minute and just quickly show you what I'm talking about. We have to be able to show a line here and a line here. And that's going to give us our 2D perspective of that slot running on our top view. So I'm going to click into here. What's the best way to do this? Well, I can add an offset. So if I go up to my modify tools, left click offset, and you know how to use this command now, it says specify distance. Well, the distance is going to be 44. Type enter. Click this line and click over to the right. And it's the same on this side, so I can left click this line and click to the left. and then right click, left click, enter to end the command. Now, these aren't long enough. They need to extend all the way to the other side of the view. So let's see if we can do that with a grip. If I select this line and then grab it at the grip at the node, I can come down and find what's called the perpendicular snap. When I see that, I'll left click. I can also do the same with this one. Select it, use a grip node, come down and find perpendicular. And then you can hit escape to deselect these grips. Alright, so now that view is fully completed. If your perpendicular snap is not working, come down to your object snap, which is right here. Right click your mouse, left click object snap settings, and make sure that perpendicular is checked on if it's not. And then when it is, hit OK, and you'll be in good shape. Alright, we've got one more view to work on, which is the right side view. So we're going to grab our line command again, zoom into the last origin, pick up the endpoint in the same position you're used to, and we're going to come up. This should be no lower or higher than this line. So we can type 41.5 or O-track it. If I O-tracked it, you can see that green beam horizontal line, and it's previewing 41.5 for me. So I'll just click my mouse. I don't want to click when I see this endpoint here because then it'll want to snap to there. So let's track it. Okay, no endpoint, snap to scene, left click. I'm going to be coming over now. The drawing tells me that this is 50 wide. So I'm going to key in 50, enter, come down, track here, and let's see if I can close this. So we're going to go C, enter to close the command, and it works. So when you close, it automatically exits you from the command when you're finished, which is pretty handy. Okay, so there are our three views. Now, of course, we're not done yet. We still need to add some information to this view and also the front view still. We need to be able to show the slot that's seen from the right side here. Now, we can't see it clearly because this is the right side of the view, but it's also identical to the left side, right? Because this is symmetrical. If we cut this control bearing in half, it would look the same. We get a mirror image of it. So we're just basically creating this vertical line here and the one you can't see here, but they would be basically these lines here, which you can see on the left view. But we're not drawing the left view. And this is where students get confused. But we'll talk about that another time. So let's click back into the drawing. To be able to do this, we know that this line here is worth a value of 11 millimeters. Same here, here, and here. So we're going to offset, and our offset value is 11. Type that in, hit enter. Select this line, click to the right, select this line, click to the left. And that will represent that slot. Now that is everything that we can clearly see with our eye, right? When we look, if we were looking at these views in real life, actually looking at the object, this is how it would appear to us. Exactly. Now we have to add something extra in a drawing, in a mechanical drawing. So we also have to show features that can't be normally seen by the eye. Meaning that when we look at the control bearing from the front view, we can't see these slots here because they're hidden from our eyes, right? We can't see because this and this blocks So we have to represent it with what's called a hidden detail line. So I'm going to show you what that looks like. We have to basically create another offset from this line to the right and this line to the left, but we need to know how far it is. So the depth of that slot is 10 millimeters on both sides. So we're going to use an offset again. So select offset. Distance is set for 10. Hit enter. Select this line and click to the right. Select this line and click to the left. And then you can right click, left click, enter to end. Now we have to change the way these lines look, because anything hidden from our view cannot be white. Basically, the white lines are the darkest lines on a drawing. They've got the heaviest contrast and basically show the outline of the part that needs to be manufactured. It was the same in the single view drawings, but we didn't have hidden detail lines in those drawings because they were just single view drawings. So what we have to do is select these two lines with a grip, go up to our layer manager drop down, which you've done before, and now there's an extra layer here called hidden. So let's select that, and what it does is it turns those lines blue and it gives them an even dash automatically. So that is how that should be represented. Everything on a drawing view that cannot normally see, any feature that cannot normally be seen by the eye, must be represented in this way. Right? Because when you look at this from the front, you can see that these slots exist. Right? It's easier to understand, I think, when you look at it in the three-dimensional view. We have one more hidden line that we have to add. And when you look at this from the right side view, we have to show and represent this slot that runs through the width in the middle. Its height is 20 millimeters, as seen in this dimension. So we're going to click back, and we can do another offset. So we can right click, left click, repeat offset, because it was the last command I used. Type 20, enter. Select this top line and click anywhere below. It'll offset at 20 millimeters. That's right click, left click, enter to end. Select this line. Go up to our layer drop down and select hidden again. It's always clunky for me to deselect these lines because I like to hit escape. And I mentioned that before, I can't. Alright, but that is the control bearing fully completed in terms of drawing views. Now the top view does not include any hidden detail lines because there's nothing hidden from our view, or hidden from our line of sight, I should say, when looking at it from the top. Right? When we look down on it, there's nothing that is shielded in terms of the structure of this part. Only when we look at it from the front, and only when we look at it from the right on the views that we've created.